Hello everyone, my name is Daryl. I work as a software developer, and in this video you'll see how I naturally work through a LeetCode challenge. This is a problem that I'm seeing for the first time, and I'll explain myself as I work through it. My solution won't likely be the best or most efficient. It'll just be the one that I come up with first as I am working through the problem. So today we have another database question. This one is number 184 on the LeetCode site, department highest salary. So here we have an employee table. It has 4 columns. You got ID, name, salary, and department ID. And we have an int, varchar int. ID is the primary key, department ID is a foreign key that links to department table, which is down here. Each row of this table indicates the ID, name, and salary of an employee. It also contains the ID of their department. And the department table just has an ID and a name. ID is the primary key for that table. Each row of this table indicates the ID of a department and its name. Write a SQL query to find employees who have the highest salary in each of the departments. So they show an example down here. So you have an employee table with these 5 employees, and you have just IT and sales as the departments. And it outputs IT, Jim, and 90. So both Max and Jim have the highest salary, okay? In IT, and then sales, Henry has the highest. And the ordering doesn't matter. Okay. So I'm thinking of using rank for this. And then you can filter, so ranking, getting a rank for partitioning on the department ID, and then just selecting where the rank is equal to 1, and you just don't need to include the actual rank in the result columns. So, in fact, you don't even need to, oh, well, you do need to join the department table because you need the name. Okay, so we're going to select... well, this is going to be, it's a name in the, okay. We'll call it d.name as departments. Actually, instead of using rank, because, okay, so I could use rank, in that, but I would probably need an outer query to make sure it doesn't return as a row. But we could also just use an inner query. I'll just use an inner query for this. So you're going to select that, name as employee, salary as salary. So it actually looks like, okay, now it's capital. Okay. So it's going to be from employee inner join departments D on department ID is equal to d.id, where the e.salary is equal to, so it's going to be select max salary, and I'm actually going to format it like this, just because this is going to be a query. So select max salary from this, but we want this to be E2 and D2. And actually, you don't need the join on the departments for this one. Where D or E dot department ID is equal to E2 dot department ID. Yeah. So you're going to select all this data from these tables where this employee's salary is equal to the max salary from that department. Let's try running that. Okay, so the first example worked. Let's do a submit. All right, that worked. So once again, there are apparently other faster methods, which is always interesting, but we didn't use any RAM, so that's fantastic. So quickly going over this one. This one's also pretty simple. Surprised on the site at some of these SQL ones that they list as medium, although I work with SQL every day and have since 2017, so maybe that's why these are pretty easy. So we're just selecting this data from the employee table, doing an inner join on departments. So that means that we're excluding any records where the departments don't match, but in this case, I believe they will always match anyways. And we're filtering it where we're only getting employees where their salary is equal to the maximum salary in the employee table for their department. And that's basically it. Thanks for watching. Hope that helped you guys out. Catch you guys next time.